Hey Year 8s, we're going to work on investigation 10.5. Okay, it's in your booklet on page 443. It's investigation 10.5 and it says in a line or side by side. The aim, and you should have this written down for your prac report, to compare series and parallel circuits. Make sure you've got the date. Your partner could be Professor Bones. He's here to help me out, so you could put him down. Remember, materials and method, you just refer to page 443. Okay, let's get started. So, for the first one, it says, connect one globe and battery together, the battery I'm using the power pack, together with wire leads, alligator clips, so that the globe lights up. I've put it on 4 volts because we're going to have more than one globe eventually. These globes should be able to handle 6 volts. So I'm going to turn it on, and you can see the electrons are going to come out of the positive terminal, run along this alligator clip, go through, and on the back you can see it's all connected up there. Okay, so it's a complete pathway. It's going to go through the load, which in this case is the globe, and then it's going to go back to the power supply to gain more power, or volts. Okay, so you can see the brightness of that globe, and we're going to need to compare it to the other globes. All right, so one complete circuit. So from the power pack, one complete circuit to the globe. So it has a complete pathway. Right, turn it off, safety first. Next step says add a second globe in series. So we still only need one pathway. I'm going to take this alligator clip off, put it onto the second one, and then I need an alligator clip to connect the 2 globes together for a complete pathway. Okay, they're in series. It's just one circuit, one complete circle, all right? Series, both next to each other. That means the electrons have to run through this globe and need to then run through this globe. At this point, I want you to be thinking about voltage and current. So voltage, how much energy they're each going to receive. It's on 4 volts. And the current, I don't have an ammeter set up, but that's the speed. So think about, is the speed going to be the same through both the globes, or is it going to be different? Doesn't really say this in the method, but I am preempting. Turn the power pack on. Now, you should be able to see the brightness of those globes. I want you to compare it to if we only had one. So bear with me, I'll go back to 1. That's the 1. Have a look. What's happened? What's happened to the brightness of those globes? Is it brighter, the same, or duller? Okay. Then it says remove one of the globes from its holder. Make note of that observation. What happened? What have I done to the pathway by removing the globe? Let's just check. So I've removed the other globe. What's going on? Think about your pathway. Can those little electrons get all the way around? Question 1 then says, draw a circuit diagram to represent the circuit that you have connected. So we need a circuit with 2 globes in series, side by side. Does the brightness of the 2 globes compared with the brightness of the single globe connect to the same battery? Okay, remember I asked you to take note about the brightness. What effect does the removal of one globe have on the other globe when the battery is connected? And does it matter which globe is removed? So you should be able to answer all those questions now. Okay, second part, then there's a discuss and explain. What I would actually do is I would leave that until you finish part B. So I would do part B and then come back to the discuss and explain, which we would put in our discussion section. So part B, connect the two globes, battery and wire leads as shown in the diagram. So if you have a look at the diagram, the actual globes are in parallel. Now this can get a little bit tricky. Start with one globe. Just connected up one globe just to check. Yep, it's glowing. Okay. Now, from there, it wants you to put it in parallel. So to do that, I need a second circuit. I need two pathways. There's already one here. I need a second one here. Okay, so now I've got those alligator clips out of the way so I can connect a second. I'm going to go to there, to there. From this globe, we don't cross our wires over, to this globe. So when you are setting them up, do try and make sure you're black to black, you're red to red. Doesn't matter what happens here. So now they are in parallel. I'm just going to show you. You can see that there are now two pathways that the electrons can flow. You've got the pathway to your first globe, or they can take that other alligator clip and go to the second globe. Let's turn on the power and see what happens. They both glow. Okay, they're both the same brightness at this point. Let's take one globe out. Let's take this one. Okay, let's see what happens. Remember what happened when we had it set in series? This is now in parallel. Think about the pathways. Think about your electrons trying to move around. I want you to also think about the brightness. Is it brighter, the same, or duller? I'll put the other globe back in. I'll take this globe out. And just to make sure, I will take the second globe out and just go back to a single one. Okay, and then the questions for that one in the method is draw a circuit diagram to represent the circuit that you have connected. You can either use the video or you can use the one on the sheet. You just need to turn it into an actual circuit diagram. How does the brightness of the two globes compare to the brightness of a single globe? What effect does the removal of one globe have on the other? That question is just asking you to note down what you observed. What happened? Did the other one glow? Did it not glow? Did it glow brighter, the same, or less? Then question 11, does it matter which globe is removed? That was shown in the video. Now question 12, outline whether the removal of one globe has an effect on the other globe. This is now asking you a bit more about the science behind it. So you might need to read back over your current and your voltage. It was on page 443 underneath bright lights. There's a really good explanation there. Okay, so what outline whether the removal of one globe has any effect on the other globe. I want you to discuss the science behind it. 13. What would be the effect on the other globes if a third globe was added in parallel? Design a circuit to test your prediction. I'll actually set this up, okay? Pause the video Make your prediction. Okay, here is our, which I'm not tall enough. Power pack, you've got your first globe, then you've got your second globe in parallel, and then your third globe. So they've got their own pathway. If we have a look, maybe I should have done a colour coding. That would have helped, wouldn't it have? I'm sure you guys will be fine. Okay, there we go. Okay, we're going to turn on the power, set it for volts. We have 3 globes in parallel. If I sit them a bit closer together, you might be able to compare. Look at the brightness. What if I just took an alligator clip of this one? Took an alligator clip of this one. Okay, so now at this point, you've got your discussion. So in the discussion, you'll answer question 5, 6, and 7. And for discussion of part B, you'll answer questions 14 and 15. Once you've done that, I then want you to write a conclusion, and that is your report done.